So I'm doing this combo, I guess, of graphing ellipses and graphing hyperbolas. We have the basics down, you know what the equations look like. I figured they'd actually be best done together so you could see what the differences are, what the similarities are, things like that. All right, so this one, first thing that you want to come up with is kind of all the details of, you know, what the center is, what the axes are going to be, things like that. So the center, you always take the opposite of the x value and then the opposite of the y value. They're in parentheses like that, so you're always taking the opposite. So this would be +5, and make sure you take the x first, even though these are written out of order, and then -1 for y. So start yourself off with that. So remember, we're not actually marking the center as a point, you just kind of, you know, mark where it is, 2, 3, 4, 5, and then down to -1. So that's where our center is. And then we're going to be able to go from there. So this one, since there's a larger number under the y, this one must be vertical. You're going to go a larger distance up and down. All right, so let's write it like this, like distance to the vertices is going to be the square root of whatever that is. All right, so square root of 64, which is 8. So that means that from this center, I'm going to go 8 units up, 8 units down, and then those will mark the vertices, which will be the edges of my ellipse. So 1, 2, 3, 4, 5, 6, 7, 8 units up. I'm going to be off this grid. I probably should have scaled it, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that is my vertical axis. And then the distance to the co-vertices is the square root of whatever this number is. So square root of 28, which doesn't come out evenly, but you can always just plug in and get a decimal approximation. So you'd plug in square root of 28, and it's about 5.3. Okay, so about 5.3. So we're just approximating, it's not a big deal. So go 1, 2, 3, 4, 5, and then a little bit more, you know, just like that. And then off to the right, 1, 2, 3, 4, 5, and just a little bit more. Okay, definitely should have scaled this. That's okay. So we just connect the dots around this ellipse. And it should look something like that. Oh, these are not my biggest talent either. Okay, so we've got all of these lengths and everything. So coordinates of the center is right here. We figure out how to get to our vertices and our co-vertices. So since this was vertical, we're going 8 units. This would be up and down. And then because this one was under the x, that means this is how many units you go left and right. So it's always whatever's under the y, whatever's under the x. All right, so we got that one. This is given to us in kind of standard form for an ellipse. Let's practice how to do these. We saw these with a circle a few days ago. It's basically doing that whole completing the square thing, getting them into standard form. So what we're going to do is we're going to group up our x stuff, group up our y stuff. Anything that doesn't belong to x and y, we're going to push it to the other side of the equation. So my x stuff, I have an x squared. I have a -6x. So we kind of make those one group. And then I have a 4y squared and a -16y. That's going to be its own little group. And then the 11 doesn't belong to either group, so I'm just going to add it to the other side. So it'll be like that. Okay, so like I said, I'm doing this completing the square thing. So this one, the x squared is already by itself, so that's a good start. I just need to figure out what I add to this to complete the square. So I start with the -6, cut it in half, that gives me -3, and then square it, and that gives me 9. So I'm going to have x squared minus 6x, and then plus 9. Anything that I add, so like adding this 9, means I have to balance by adding a 9 on the other side of the equation as well. Okay, so I'll get there in just a second once I'm finishing up with this one. So now the y squared has to be by itself, so I'm going to factor out a 4. Make sure you factor the 4 from that term as well, equals, and as of right now I have 20 on the other side of the equation because I had the 11 that was already there and then the 9 that I added from this step. So let's start to simplify things up. So this, the x stuff factors as x minus 3 squared. Now I'm still working on completing the square with this piece. So this one I start with my middle term that's attached to the y, cut it in half, that gives me -2, and then square it and I get 4. Okay, so anytime that you add something to the equation that wasn't there before, we got to balance it. But be really careful when you're balancing because we had this 4 on the outside. So this is technically 4y squared minus 16y and then plus 16. So I really added a 16, so make sure you're balancing it by adding a 16, not just a 4. Okay, so let's see where we are so far. So plus, I have 4 right here. This in parentheses factors down to y minus 2, y minus 2. And I have a 36 on the other side of the equation. Okay, I am just one step away from having my actual standard form equation. Remember with ellipses, this is supposed to be a 1. So since it's not a 1, I'm going to divide by 36 so I can make it a 1. But that means I've got to divide the entire left-hand side of the equation by 36 as well. So here's what we've got. There was nothing in front here, so this just becomes x minus 3 squared and then divided by 36. Plus, and then the 4 over 36, that reduces down to 1 over 9. Okay, so there we go. We are finally in standard form for the ellipse. I'm going to write down our important stuff. So our center, remember, is opposite of x, so positive 3, and then opposite of y, positive 2. And we're going to get our distance to the vertices and to the co-vertices. All right, so our vertices, underneath here, I have a 36. Square root of that would be 6. So I go 6 units, and because it's under the x, that means I'm going 6 units left and right. All right, and then for my co-vertices, underneath the y, I have a 9. Square root of 9 is 3. And because it's under the y, that means I'm going up and down. Okay, so start with my center. Go to 3, 2. Remember, we don't actually plot a point, we just mark it. That's our center. According to my vertices, I'm going 6 units left and right because I had a 36 under the x. So I'm going 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and then underneath the y, I have a 9. Square root of 9 is 3, so I'm going 3 units up and 3 units down, and then just connect the dots. And that is your ellipse. All right, so that is graphing the ellipses. Let's take a look at the hyperbolas. So flip back to the second half, here we go, of your hyperbolas. So this one, we just want to recap how these shift left, right, up, down. So remember here, if the x is first and then you subtract the y, that makes it a horizontal hyperbola. And if the y is first and you subtract the x, that makes it a vertical hyperbola. Length of the transverse axis. So under the x, that means we're going a units to the left and a units to the right. And so that would be a total of 2a units. Here under the y, we're going a units up and a units down. So again, grand total of 2a units. Here under the y, we're going b units up and b units down. So that would be 2b units. And here under the x, we're going b units left and b units right. So a total of 2b units. Same values as we had on the previous page and even with the ellipses. All right, so now our vertices. Here's where things get a little weird. So we've got this horizontal hyperbola. The center of all of these is h comma k. All right, so for our vertices, we are going to the left and to the right by a units. So I originally start on h, and then I go to the right or to the left a units. But then this stays on k. All right, if I have a vertical, I'm first going up and down a units. So I'm first not going left and right at all, then I'm starting on k and going up or down a units. And then for my for my conjugate axis with the co-vertices, here I go up and down to hit my co-vertices. So I'm staying right at h, and then starting at the center value of k, and then either going up or down b units to my co-vertices. And with the vertical, I'm going left and right to hit my co-vertices. So I start at h, and then I could go to the right or to the left b units, but I stay right here at this value of k. I'm not going up or down for those. All right, and the asymptotes, these formulas are actually pretty complicated. I'm going to write them down for you. So we go, minus k, and then plus or minus b over a. I'm just going to explain what they mean. We're not really directly going to have to use these. So same slope as we had on the previous page before any shifts were made, and then we shifted left or right by h and shifted up or down by k. So that's the adjustment. So it starts like the starting point, and then the slope is still the same. So basically same thing with this one. We would have y minus k. We just have a different slope with these. Remember, in this direction, you go a over b instead. So we're never going to directly use those asymptotes. Just know that that's what the formula would be if you ever had to come up with it, which you don't. All right, so let's graph these. These are going to be a little bit different. We're not going to explicitly identify any of this stuff. We're just going to look at the graph. All right, so let's start with our center. Our center, we do the opposites that you see in parentheses, so +3 and -5. So let's start there. Big coordinate system, +3, -5. And remember, we just mark the center. It's not a point on our graph. We just mark it so we know where to start. All right, so now to get to our vertices. Look underneath the x. I see a 4. Square root of 4 is 2. And since this is under x, I am going 2 units to the left and to the right. All right, so I am going 2 units to the right. I'll mark a point right there. And I'm going 2 units to the left, and I'll mark a point right there. So that's going to be the points where I draw my hyperbolas like this. All right, and then for my co-vertices, underneath the y, I see a 9. Square root of 9 is 3. And because it's under the y, we know it's an up and down movement. Okay, so from my center, I'm going up 1, 2, 3, put a little mark right there, and down 1, 2, 3, put a little mark right there. Okay, so follow my lead on these hyperbolas because this graphing is very strange. So I use these 4 dots and I make, remember that little dotted box. So I'm going to do this all in pink. So make your little dotted box out of these 4 lines. That's going to help you figure out exactly how wide or narrow that hyperbola should be. And then once you have the box, remember your asymptotes go through the corner, through the center, and out the other side. This is what's really going to be helpful to us in graphing these. So through the corner, through the center, and out the other side. Make sure they go down as far as you need them to. And then since this is vertical, x is first, that means we're going through these points and then using this as our guide. So it'll look something like this. There we go. All right, so we're not actually going to identify anything. Just the graph itself is going to be good enough for us. So that's our first one. We've got one more on the other page, and then I think that'll be it for that. All right, so this one of those where we've got to convert it back into our original standard form for a hyperbola. So you guys will have lots of practice with this. We're going to do the same thing we did with the ellipses. Gather up the x stuff, gather up the y stuff, push any constants to the other side. All right, so here, since they start with the y term first, that means we start with the y term first. Don't try to rearrange it. So we've got 9y squared. We also have an 18y, so that will be our group of y stuff. And then we have a -16x squared and a +64x. That'll be our group of x stuff. And then this 199, I'm going to add it to the other side because it doesn't belong in either group. We always push the constants over here. All right, so let's start doing this, completing the square term. Here I've got to factor out a 9 because I can't have anything in front of the y squared. So this is now a y squared plus 2y, and I know I'm going to complete the square, so I'm just going to leave space for it right now. Here, again, whatever is in front of the x squared, I have to factor out. So I'm going to factor out a -16, leaves me with just a +x squared. Be careful with the sign here. When I divide +64 by -16, I'll be left with a -4x. And just like with the y, I know I'm going to complete the square, so I'm going to leave space for it right now. And then equals 199. Okay, so let's see what completes the square. Here I have a 2. Cut it in half gives me 1, and then square the 1, and I get 1. But remember, this is not really just a 1. It's a 1 that was technically multiplied by 9. So 9 is the new number that I need to balance on the other side of the equation. Okay, similar right here. I've got -4. When I cut it in half, it gives me -2. Square it, I get 4. But this was really a 4 times -16. So that gives me a -64. So that is what I need to balance on the other side. All right, so let's clean this up. I've got a 9 out front. When I factor this down, it factors to y plus 1, y plus 1. So I'll write it like that. keep this minus 16. And then the x squared minus 4x plus 4, that factors to x minus 2 equals, and then on the other side of the equation, I've got 144. Okay, very last step here. That's supposed to be a 1. So I'm going to divide the right-hand side and then divide both the terms on the left by 144 and see what this all cleans up to. So 9 over 144. First of all, 9 times 16 gives me 144. So when I reduce this down by 9, I'm left with 1 over 16. And then I can reduce this down by 16. It leaves me with 1 over 9. Okay, final equation. Here we go. All right, that's my hyperbola. So my center, you take the opposite of x, opposite of y. And then for my vertices, y is first, so you know I'm going up or down. Square root of 16, which is 4 units. And then for my co-vertices, x is next, so that means I'm going left or right. Square root of 9 is 3. Okay, so basically this is all the info you need to actually plot. So let's set this up. So start with my center, 2, -1. So you go over to 2, down -1. Remember, we're just marking it. Marking the center so you know where everything begins. To my vertices, I am going up and down 4 units. So this is going to be a point on my hyperbola. And then up 1, 2, 3, 4. That's going to be a point on my hyperbola too, because this is going to go up and down. And then left and right 3. This just kind of marks a point on the little box that I'm going to draw in. Same thing, 1, 2, 3. That just marks a little point on the box. It's not actually a point on the hyperbola. So I use this, sketch in this little box. We're going to use all this to draw in the asymptotes and then see how wide our hyperbola needs to be. So we got the box, so our asymptotes will go through the corners, out the other side. All right, and we use that, and we use this point to shape exactly what our hyperbola, should look like. There you go.